So here we have a linear programming problem, maximization problem, and you notice that the feasible region for this problem is already graphed. So as you can see, the corner points I found 0, 40, 30, 20, 50, 0, and 0, 0. And what we're going to do is investigate a very simplistic thing about solving a linear programming problem, and that is that the maximum value of z under these constraints is always found at a corner point. And the reasoning is quite simple, actually. It just has to do with the nature of this line right here. So what I'm going to do is I'm going to start, notice this purple line that showed up here, and that corresponds to z equals 0. So what I'm looking for is the highest value of z possible so that it still lands in the feasible region defined by these constraints right here. So notice that when z equals 0, I'm at this corner point 0, 0. So the question is, if I increase z at all, will I still find solutions? So I'm going to increase z up to, I'll just pick 70 right there. And now notice, for any given value of z, the slope of this line is always going to be the same. In fact, it's always going to be negative 4/5. Okay? So all of these lines that represent the objective function are parallel, which basically just means if I increase z, I just shift the line up. So I want to be able to increase z as much as I can and still be in the feasible region. So notice that all of these points right here within the green area, all those points represent where z is equal to 70. So the question becomes, can I go higher? And the answer is yes. So I'm going to increase z more, and notice once I hit those, this one's actually a weird one. I didn't intend for this to happen, but I'm hitting both corner points, both 0, 40 and 50, 0, because they both give the same value of z, which is 200. The question is, can I increase z even more? And the answer is yes, because it looks like I'm going to hit this corner point right here. In fact, at 30, 20, the value of z is 220. You can double check that here. 4 times 30 is 120. 5 times 5 times 20 is 100. Add those together, you get 220. So you notice that the maximum value of z happens at that corner point, because if I even try to increase z a little bit, I'm no longer in the feasible region, which means those can't be solutions to the problem because I'm not using a viable solution. So the moral of the story is to solve a linear programming problem by the graphical approach. And this can be the minimum or the maximum. All you do, graph the feasible region, find your corner points, and then substitute each corner point into z in order to then compare in order to figure out whether or not you have a max or a min. It's basically as simple as that. So this is just the reasoning behind that. Okay, so hopefully that makes sense and hopefully that helps. Thanks for watching.